Hello everybody. This video is a mold instructional for the homework 3 assignment for creating your Fidel figure molds. This video is for the simpler molds. To be specific, if you chose to do the heart, the teddy bear, or the gingerbread man, this is the video that you'll want to watch because there's only one toolpath that needs to be created in order to complete this project. Now, prior to starting to do anything with this file, it's a good idea to make sure that you have read all the instructions for homework number 3. That will tell you where to get these files, and also it will give you the step-by-step on how you need to complete this assignment. It's also important that once you load the program or this drawing up, you probably would want to go into File and Save As, and save this file as something else. That way, if you do make any kind of major mistakes to the file, you can always go back and reload the original without having to go back to the website and download it again. When you bring your file up and you're ready to work on it, it's important that you plan out your strategy. Every good designer and every good engineer has a visualization of what it is that they're trying to do long before they draw something on a piece of paper or onto a CAD screen. So the same goes for you. You need to look at this drawing, read the notations that are on the screen, and kind of plan out what this thing is going to look like so that everything goes as smoothly as possible. To help you do that, you want to make sure that everything that you need to be seeing on the screen is turned on. And so if you're not familiar with something called levels in CAD systems, let's go over to the left-hand bottom of the screen and click on the Levels tab. Levels are like clear pieces of paper that you can draw on, and then you can turn each one of those clear pieces of paper on and off. So for instance, I have 3 levels here, levels 1, 2, and 3, and each one have been labeled with a mold plate, a heart, or notes, and it tells me how many entities are on each one of these different levels. By clicking on the visual column, the X that's on the visual column, I can turn the notes off, or I can turn them back on. Now the purpose of levels is for organization, and also it helps reduce clutter. You have a lot of information that you need to display that can be quite cumbersome to look at if you have them all turned on. So by turning these levels on and off, you can simplify the look of things and make things much more efficient. So make sure that all of your levels are turned on, and to do it quickly, you can click the All On icon right here, and that'll make sure everything is turned on. Right-click on the screen somewhere, on the graphic screen, and click Fit. That will ensure that everything on the screen is within view, and then you can read the notations that are there. On this particular project, there's only one notation, and in this notation it tells us how deep we're going to mill, the type of milling strategy we're going to be using, the tool that we're going to be using, and the feed rate the tool should be run at. So I'm going to come over to the tabs toolpath over here, and the first thing that you'll see is that there's already 4 operations that have been created for you. Now these operations you do not need to touch. So please do not go in there and start changing things, because if you do, there's a possibility that that change can cause a crash. What are these operations? Well, besides the pocketing that needs to be done, in order for this mold to function properly, remember we talked about the 3 F's, fit, form, and function. And the function of this mold is to make something, right? We're going to fill it with chocolate or rubber, and we're going to make a molded object. For that to happen, we have to put in these dowel pin holes. And these dowel pin holes have to be accurate. They can't just be a drilled hole, because we're going to be press fitting some 1/4-inch steel dowel pins into each one of them. For that to happen, it takes 4 different tools for that to do the complete operation. We're going to be center drilling, which is going to make a spot mark in each location. We're going to choose a drill and come back, and that's going to pre-drill the holes, and then we're going to grab a reamer, and the reamer is going to size the holes to the 4th place decimal, making it an accurate tight fit. The other tool that we're going to use is come back to our first tool, which is the spotting tool. We're going to actually use that same tool as an engraving tool, and we're going to engrave a scribed line down the center of the mold so that you know where to line it up on the bandsaw when you split your mold in half. So again, just to reiterate, don't touch these operations. They're already taken care of, and it will save you some time. We can concentrate just on the milling aspects. To create your new toolpath, you're going to right-click anywhere on the white area of the toolpath screen, click on Mill Toolpaths, and come down to Pocket. We're going to choose our chaining option, which is going to be chain, and we want to chain these two pockets in a counterclockwise direction. So we're going to click here, and we're going to click here, and our arrow should be moving upward counterclockwise. Then we're going to click OK. Now our toolpath menu opens up, and I'm not going to spend the time that I did in the first video of explaining what each step and each operation does. I'm going to move fairly quickly through the settings and parameters to make this video as short as I possibly can. If you have questions about why we're filling out certain areas or what they do, please make sure you go back and watch the first video, which is called Pockets, Contours, and Engraving, because that's where I go into a little bit greater detail and explain what each one of these settings are for. So the first thing we want to do is we want to go to our first setting called Tool, and we need to make sure that we have a Tool 5 called up. Now if you don't have one in your settings, you simply go into Select the Tool, make sure you have the proper tool type called up here, and if it's not, go into Filter and filter it out so that you're looking at just end mills. Find the tool, click on it, and say OK. Now I already have a tool set up for me here called the 3/8 end mill, and I've already assigned it the tool number. When you click a new tool, some random tool number will come up here, and you'll have to click into the box, give it the right value, press the Tab key, and make sure that the tool, the length offset, and diameter offset are all the same number. Now we're going to modify our feeds and speeds to be proper for this mold and this material. We're going to make it 1600 RPM, and we're going to feed it at 12 inches a minute. You can put in an optional comment if you want to. I'm going to put in pocket both sides. And then I'm going to move on to my next parameter, cut parameters. I'm going to make sure that pocket type is set to standard, and then I'm not going to leave any stock for this pocket. I want it to finish it completely. I'm going to move to the roughing area, and I'm going to choose the proper strategy for pocketing. In this case, it's parallel spiral. So we're going to pick the parallel spiral. We're going to accept the default of 50%. We're going to click on our entry motion, make sure that helix is selected, and change our Z clearance to 0.01. From here, we'll click on finishing. We'll make sure that we're leaving 10 thousandths, and the computer will do the cutter compensation where it takes the final 10 thousandths out. Our lead in and lead out screen we need to set to perpendicular. Our length that we'll lead in at will be 0.1. Our sweep will be 90 degrees. I'm sorry, 45 degrees. And then we want to copy the entry motions into the exit motions by using the copy button right here. From here, we're going to make sure that we don't use any depths of cut, so this should be red. Same with breakthrough. We'll go right to our linking parameters. We'll click our clearance on, and we'll make sure that all our values that we enter will be considered absolute values. We'll change our clearance to 1.0. We'll change our feed plane to 0.1. And we'll change our depth to -0.1 because we want to mill into the part. Lastly, we will set the coolant and make sure that flood coolant is turned on. We'll say OK. It creates the pocket, and if we want to see the pocket, just expand that operation and click on the toolpath and then click the play button. And you can see the pocket being generated. If I press my middle mouse wheel, I can see that I'm going just below the part surface. Let me see if I can get this a little straighter here by the 100 thousandths, and it's creating the pocket for us. Once it finishes the pocket, it goes back and does the finish routine, taking that last 10 thousandths out. I'll right click and go back to my top view. I'll click OK to close our toolpath backplot option, and that's it. So the next thing we want to do is verify what this looks like. So we need to make sure that our stock is set up properly so that we can use the verify function. So we're going to expand the properties menu here by clicking the plus sign, and we're going to click on the stock setup. We're going to pick select corners. We're going to pick the upper left hand corner and the lower right hand corner of our mold plate, and we're going to enter in the Z value here of 0.375, and that will give us the thickness of the piece of plexiglass that you'll be receiving. We're going to say OK. Once the stock is set properly, we're going to go into the verify selected operations, and notice only one operation is selected. So I want to select all of these operations by clicking these 4 blue dots and making sure that the check mark shows up on everything. Then I'll go back to my verify button, let the verify window open, and then I'll right click on the screen and tell it to go isometric. From here, if I want to toggle on or off the wireframe geometry, I can do so by clicking it up here. I'm going to set my precision to the middle, and I'm going to change my pocketing speed to be just a little bit faster. I might slow it down for a second run just to look at it, but we'll try it there and we'll click play. So what you should see is it drill holes, ream the holes, and finish the pocket. Now that happened very, very quickly. So if I go back and slow this down quite a bit and rewind it and then click play again, you'll see it center drill, and then ream, and then pocket, and then it will finish the contours of the pockets, and it creates our mold. Now from here, your assignment says that I want you to print this picture out. So what you'll do is you're going to press your print screen button, which will copy it to the clipboard. Right? So I'm going to say no thanks on that little message that popped up, but that image should now be on the clipboard. And now we're going to go back and we're going to right click, go back to our top view, and we're going to make sure that we save our file so that you have it for to bring in for the day that we run it. And now we're going to open up the Paint program. So we're going to click our Windows button. We're going to type the search word Paint. Of course, you can use any other graphics that you can paste into. And from here, I'm going to click Control V to paste in the image that I put on the clipboard. And then from there, you're simply going to save this file. And when you go to save it, say Save As. Save it as a JPEG file. So pick the JPEG type, which is right here. Give it a file name. In this case, I'll just call it HRT dash my initials. And then after you save it, I'm going to save mine to the desktop. You save yours wherever you like. You also want to print this page out. So make sure that you go back up and you print it. I'll send it to my printer. And you would do the same thing. And then this is one of the documents that you'll be bringing in. Make sure that you put your name and your Panther ID and your lab number on the printed document. This is to show me that you've created the toolpath. It gives me a quick visual of what it looks like. We'll verify it in the classroom, but we'll also make sure that, that by seeing this graphic that I can see right away whether something's not right. So that's it. I'm going to go ahead and close out of this Paint program. Again, make sure that you do save your Mastercam program and save it on a USB drive. And that ends this tutorial. Thank you for watching.